Find the inverse of the following matrix if it exists. So I have this beautiful 2 by 2 matrix, and I'm going to go right ahead and label this as the matrix A, B, C, D. Now, we are asked here to find the inverse of this matrix if it exists. So the first thing that we need to do is check that the determinant of matrix A does not equal 0. So here we go. We have the determinant of matrix A, which we know from our 2 by 2 definition is AD minus BC. So we have 3 times 6 is 18 minus 2 times negative 9 is negative 18, leaving us with a beautiful final answer of 36, which does not equal 0, and so we know that A is invertible. Woohoo! So since matrix A is invertible, we can go ahead now and find the formula for its inverse. So we know, again, from our 2 by 2 definition, that the inverse of matrix A is defined as 1 by the determinant of matrix A multiplied by the 2 by 2 matrix D minus B minus C A. So plugging everything in, we have 1 over the determinant, which we found to be 36, multiplied by the matrix 6, positive 9, negative 2, 3. And so by properties of scalar multiplication, we're going to pull this scalar 1 by 36 through to each term in our 2 by 2 matrix. So this is going to be equal to, so we have 6 by 36, 9 by 36, negative 2 by 36, and 3 by 36. But of course, we don't want to leave our answer like that. We want to simplify. So we're left with a answer of 1/6, 1/4, minus 1/18, 1/12. Now, before we go ahead and assume that this is the correct answer, we should check. Checking that this is an appropriate or the correct answer is so quick and easy, it's worth checking. That way we get 100 on our quizzes and all of our exams. So here we go. We want to check that matrix A, the given matrix, multiplied by this inverse formula is the 2 by 2 identity matrix, which is also equal to the inverse of matrix A multiplied by matrix A. So we have 2 things that we need to check here. Let's first think about matrix A multiplied by the inverse of A. So we have the original 2 by 2 matrix, which is 3, negative 9, 2, 6. And we're going to multiply this by the 2 by 2 matrix we just found. 1/6, 1/4, negative 1/18, 1/12. And so I'm going to use the row column rule to check. So here we go. We have the first row of matrix A multiplied by the first column of the inverse, which leaves us with 1/2 plus 1/2. We have the first row of A multiplied by the second column of the inverse, which leaves us with 3/4 minus 3/4. Then we have the second row of A multiplied by the first column of the inverse, which is 1/3 minus 1/3. And last but not least, second row of matrix A multiplied by the second column of the inverse leaves us with 1/2 plus 1/2. And again, that's by the row column rule. And look at this. We are left with the 2 by 2 matrix, 1, 0, 0, 1. Woo! And we know that is the 2 by 2 identity matrix. So our first case is all set. And now, keeping in mind that matrix multiplication is not necessarily commutative, we want to make sure that the product of the inverse of matrix A with the original matrix A is also equal to the 2 by 2 identity matrix. So here we go. We have the inverse of A was 1/6, 1/4, minus 1/18, 1/12, And we are multiplying this by the original matrix A. 3, -9, 2, 6. And by the row column rule, we have the first row of the inverse multiplied by the first column of matrix A. So that's 1/2 plus 1/2. We now have the first row of the inverse multiplied by the second column of matrix A. So that is leaving us with -3/2 plus 3/2. We now have the second row of the inverse multiplied by the first column of matrix A, which leaves us with -1/6 plus 1/6. And last but not least, we have the second row of the inverse multiplied by the second column of matrix A, which leaves us with a positive 1/2 plus 1/2. And simplifying, we have the 2 by 2 matrix, 1, 0, 0, 1, which again is that 2 by 2 identity matrix. Woohoo! So we have verified both cases and can now officially conclude that yes, what we found above is the inverse of matrix A, and our beautiful final answer.